Hello there, and then welcome to a brand new video. This is How Beyond Numbers, where we learn maths the easy way, and I mean the very easy way. Now in this lesson, we are on Venn diagram with two sets. By the end of this lesson, you should be able to draw Venn diagram involving two sets and interpret Venn diagram to identify union, intersection, and complement. In our next lesson, we will look at word problems involving Venn diagrams as well. So without much ado, let's quickly look into it. So when we talk of Venn diagram, as you have seen displayed, a Venn diagram is a diagram made up of overlapping circles, each representing a set within a rectangle. You see, and the rectangle represents your universal set. Get it? Your universal set. There are two set Venn diagram, and then there are three set Venn diagram as well. But we'll be looking at, for this lesson, we'll focus mainly on the two sets. Okay, we focus mainly on the two sets. In that case, let's look at what the two sets Venn diagrams are. So for a two sets Venn diagram, let's take A as one set. Okay, so this here is set A, and then let's take another set B. You get it? So set B over here, and then let's get a rectangle to represent the universal set. Now, we know that the universal set is always the set under discussion. That is where we are taking all our sets from. You get it? That is where we are taking all our sets from. But how we draw our Venn diagram will depend on the relationship between A and then B. Okay? So depending on the relationship between A and B, there are two ways we can draw our Venn diagram. So first of all, if we have our universal set, A over here, if it happens that both A and then B are inside of our universal set, that is, we have A in the universal set and B also in the universal set, and there are elements in A that are also in B. Okay, so there are elements in A that are also in B, then this is how we write them, or this is how we draw them. So that we will have A over here, B over here, and then our universal set written outside over here. Now, because they have elements in common, they do have elements in common, then we make sure their circles overlap. And that overlapping is what we see over here. So you realize that circle A and then B do overlap. Take note, this here is our A. You see, this is A circle. Let me use another color. So this here is A circle, and this here is B circle. And as you can see, there is an overlapping in here, such that part of A and then B they've overlapped. You get it? This means they have what? Elements in common. And this overlapping here, we call it the intersection. We call it the what? Their intersection. So this here, since we are talking of set A and B, is going to be A intersection B. You see, this is for A intersection B. And as I said, this is how we draw a Venn diagram. If A and B have elements in common. So you see, if A and B. Now, what if they don't have elements in common? Okay, what if they don't have elements in common? How do we represent them on a Venn diagram to show that they are all in the universal set? So once again, we have our set A and set B. You see, if they don't have elements in common, then this is our universal set over here, and A comes to be at one portion of it, whilst B also comes to be at another portion. I'll have to make the universal bigger. So something like this, you see. And as you can see, there is no overlap. There is no overlap. You get it? So the yellow one is going to be our A, and B is going to be our white one. And let me make the universal blue. You see, there is no overlap. This is our A, this here is our B, and we have all in our universal set. So this here is used to show that what both sets do not have common element. All the elements in A are not in B, not at all. And the elements in B are also not in A. And hence, this here is A only. This here is B only. All in our universal set. So in this case, we are saying when A and intersection B. So when A intersection B is equal to 0. Now, since we are focusing on the Venn diagram of two sets, we would want to identify or be able to identify all the regions. You see, well, we might not be able to look at all, but if you understand this basis of how we are able to get out the regions, there is none that you can't. And for that matter, let's look at this first one over here. So for this first one, our region, or for most of the Venn diagrams I have drawn, our region in focus is the one in white. The one in white. So over here, this white here represents everything you have in A. It represents everything you have in A. So we call this set A. You get it? So set A. That is in English, we just write set A. Okay. Now, it is obvious that the second one here is then going to be B. So set B. But for this third one here, we have shaded their intersection. You see, and we said intersection, part of this shaded region belongs to A, and part of the shaded region also belongs to B. You see, so we call it A intersection B. You see, A intersection what? B, written as A intersection B. So those are these first three regions we have drawn over there. Now we move to a little bit more complex ones. For this here, you realize that we have shaded all of A and we have shaded all of what? B. I'm taking it again. We have shaded all of A and then all of B. So this becomes our A union B. It is a union of all the sets, written as A what? Union B. A union of all the sets. This over here, we have shaded everything that is outside the union of A and B. Outside the union of A and then B. So we say we had our A union B, but we didn't focus on it. We rather went for their complement. Remember, we said the complement is what is outside the set. So this here is the complement of the union of A and B. Complement of the union of A and then B. Then let's look at this one over here. It is also one interesting case. If you take a critical look at it, our only shaded region is what we have only in A. So originally, A would have been all of this circle. But we know from the intersection here that even though A is all of this circle, B forms part of it. You see, so we are taking out that region that B forms part of, so that we are looking for those that are strictly in A. You see, strictly in A. You get it? So in English, we write this one as A only. A only. But if we want it mathematical notation, that one you really have to take your time. So first of all, let's take A union B. Okay. So if we take A union B, then out of our A union B, let's take out B. That is what will give us what we have over here. So mathematically, we write it as A union B that has the B being taken out. So we call it A union B prime, or you can write it as A union B complement. A union B complement. You see that? So for the complement, you can either use this symbol here, you get it, this symbol here, or you can write the C on top. So A union B complement, that is the region A only over here. Or better and easier still, you can write it as A minus B. A minus B. I think this one is simpler and then you can easily understand. So that is it for this three. Now let's look at some two more. Obviously, this one here is going to be B minus A, or in English we call it B only. B only. You get it? Then for this last one here, realize that we have all of B inside A. You see? So with this, you can say that B is a subset of A. B is a subset of A. So basically, these are what the Venn diagram representations you are supposed to know. You get it? And if you know all of this, there is no word problem that can beat you. In our next video or in our next lesson, we'll look at the word problems, and based on the understanding we have established here, we'll be able to tackle such problems. So that is it for this lesson. This is Half Beyond Numbers, where we learn maths the easy way. If you found this video helpful, you can always choose to subscribe so that anytime I do release a video, you'll be notified as well. Stay safe and then stay blessed. Bye.